Hi, I'm Shafreen from AWS, and welcome to another episode of This Is My Architecture. Today we're being joined by Robin from Inawisdom. Thanks for coming over, Robin.
You're welcome.
Cool. So tell us a little bit about your role and Inawisdom.
So I'm the CTO and co-founder of Inawisdom. So we're about machine learning and AI on Amazon Web Services, which also gets us involved in ETL and data warehouse and data visualization type activities. We're an Amazon consulting partner, an advanced partner, and we have the machine learning competency.
Right. Can you talk us through some of the technical challenges that you're seeing within the industry where customers are using machine learning?
Sure. So I guess in the machine learning world, building the initial models, or training the initial models is largely an offline activity. But then once models are in production, then they tend to drift over time because the environment they're operating within drifts. So it's not so much the model's drifting, it's more that the environment they're within is drifting.
Right.
So there might be customer behavior changes or say interest rate changes or that kind of thing.
Yeah.
So what that means is that you need a mechanism of identifying when your predictive models are slowly reducing in accuracy and identifying that, then deciding when to retrain them to improve them. And then you need a controlled, sort of safe way of deploying it into the production life cycle again.
Cool. So could you talk us through a customer use case that you're seeing?
Sure. So a common use case for customers that we've worked on is around collections management, so collecting payments from our customers, our clients' customers. And I'll use that just to bring out all the kind of core principles and walk that through. So if we imagine that a customer has a system that's managing their collections, so maybe there's outbound telephony calls being made to collect payments, maybe outbound SMS, outbound email. So there's a core set of collections agents who are using a collection system. What we'll do initially is we'll take data from that customer system, probably in a batch offline way, stored in S3, and then our data science team will use that and use SageMaker to build some predictive models to optimize the collections process. So this is all about improving the efficiency of the collections process, improving the amount of money that's collected and the human resources required to collect it.
Right.
So that data science team builds some predictive models, so it might be more than one, and that's obviously quite a intense discipline using the SageMaker Jupyter notebooks, so hosted Jupyter notebooks, SageMaker notebook instances. Those models are then stored into S3 by SageMaker. So that's the training cycle.
Bit. Right. So how do you then invoke the models?
Yep, great. So at invocation time, so the invocation path is from the customer system. So let's imagine on the classic approach is on the collection system, we want to show which customer to call next or chase next or maybe do automated outbound SMS and email. So we'll make invocations from the customer system, so a REST call to the API gateway, which invokes Lambda and ultimately invokes the machine learning models on a SageMaker endpoint. So the SageMaker models which are held in S3 are then deployed as a SageMaker endpoint. That's what's called through with a REST call.
Right, so that is the training bit. Well, why don't you call the SageMaker endpoint directly?
So we could do, it's certainly possible, so we could just call from the customer system straight to the SageMaker endpoint. So often there's maybe a mobile device that we want to make invocations through with as well. So it's not sort of on-premise systems, it could also be out on the web, which would use the same call chain. So the reasons for this architecture, so the API gateway gives us all the security features, authentication, throttling, monitoring, and stage deployments and all those good things. So it's a good sort of edge protection, especially for the mobile devices. The call through to Lambda gives us a couple of capabilities that we really need. So one is around data preparation. So we might have, typically you would have some string values as well as numeric values. So they're called categorical variables, categorical features in machine learning. So we need to translate those to numbers from strings using typically a Python label encoder or dictionary type model. So we can do that in Lambda before we invoke our SageMaker endpoint. Also, we want to do aggregation of calls, so we might have 3 predictive models that are predicting different features that we want to bring back. So Lambda might invoke 3 times, aggregate into one JSON response and bring it all the way back to the client. The last thing to say is that if we want to do direct access from a a browser client, then the API gateway supports CORS. So that means we can do cross-domain behavior on the web client and not have any issues.
Cool, that sounds good. So apart from the training and invoking the model, is there anything that you guys are actively doing to retrain the models in order to improve the accuracy?
Yes, so getting onto the challenge of how you keep the model fresh as the environment drifts around it. So what we do here is we have a scheduled process, so scheduled EC2, in fact with scheduled cron on top, and this will periodically be checking the performance of the model in production. So is the model still performing to the accuracy that we got when we initially trained it?
Right.
When it falls below a certain threshold, what we'll do is we'll automatically trigger SageMaker training. So we'll be running the same SageMaker notebook code, essentially, so exactly the same code, so we know we'll get the same output, which could still include hyperparameter optimization as well. And we'll train a new model, so orchestrated by that EC2 instance, which again causes a new SageMaker model versions to be deployed in here.
Right.
The results of the training are stored into CloudWatch in terms of the model evaluation metrics, so how accurate the models are. Then when it comes to deployment time, you've got to be very careful. Typically, you want a human in the loop to manage the deployment cycle. So what they will do is they will look at the CloudWatch metrics to understand how the automatically trained model is performing compared with the previous version of the model. And then they'll be able to run a small script that automates the deployment of the new version into the SageMaker endpoint. And that's done without any interruption of service, so which is a really nice feature of the SageMaker endpoint. So it's auto-scaling, platform as a service essentially, but means we can deploy without any interruption of service. And finally, that allows us to do some A/B spreading of the load. So through weighting of the endpoint, we can have 10% of the traffic on the new model and say 90% of the traffic on the old model, and then switch over once we're confident.
Cool. That sounds great from a security standpoint, from a scalability perspective. I mean, this looks great, and it's nice and simple to get started with training, building, invoking, and reiterating machine learning models. So thank you for sharing your story with us, and thank you all for watching another episode of This Is My Architecture.